Well, hello everybody. Welcome back. This is it, chapter 13. We've had so much fun, and we're going to wrap it up in week 9 so that you can spend week 10 taking the final exam, which is open book, and finishing a short diagram of a network solution in the home environment. So anyhow, look for that later, but for now, let's get through week 10 or week 9, chapter 13. So you have seen how port scanning and enumeration make it possible for attackers to determine the services and gain access. In this chapter, we're going to look at the network protection system that can be used to reduce exposure, right? The routers, the hardware, the software firewalls, web filtering, IDS and IPS, honeypots, etc. And we're even going to talk a little bit about security incident response team. So these are our objectives for this lesson. Now, when we want to start understanding the network protection systems, this book is really great, and frankly, network protection systems are just simply any device or system designed to protect the network. Just a very basic understanding, right? So we want to think in those terms as security professionals. The term Unified Threat Management, or UTM, that's a good one, because that's now a device used to describe a single item or a device that combines these many network protection functions, right? So UTM, Unified Threat Management, might include endpoint protection, might include some AV, might include some FIM or file integrity monitoring, might include some DLP, etc. But on a kind of a mini network protection type function. And so another example would be modern Cisco routers, for example. They can perform firewall functions. They can do address translation, like network address translation and port address translation. And they can even do intrusion protection. There's another example, right? EDR, endpoint detection and response. That's a common new framework for UTM also. So the security appliance can be used to describe both UTMs and network protection systems. That's the distinction we're really trying to make here. So as hardware technology gets more powerful and security appliances can perform the same functions at once using what used to take several separate dedicated systems, right? Okay, so now to start the conversation then, right? Routers, which operate on the network layer of TCP/IP, we covered that in chapter 2, they send packets to different network segments. Now their main purpose, as you recall, are to reduce broadcast traffic and choose the best possible path. So routers are use routing protocols in the best path decision in the following ways listed here: link state, distance vector, or path vector, right? In link state routing protocol, this sends the link stated advertisements to other routers. And these advertisements identify the network topology and any changes or past changes or other things that are discovered recently in the network in terms of the path. And they are efficient because there are only a little bit of information sent over the network. Now for routers using a distance vector routing protocol, it passes its routing table containing all possible paths. And it has discovered neighboring routers on the network, right? And so that's another approach. A third approach is the path vector routing protocol, which uses dynamically updated paths, used mostly by ISPs and large organizations. So as a security professional, your main concern again is confirming that the router filters they contain the traffic not designing a router infrastructure or determining the router protocol, but right that you have the right filters in place. Now, in this section, right, the Cisco routers are used as an example by many companies around the world, right? It's wildly popular. A Cisco competitor such as would be one such as Juniper. In the end, it doesn't really matter. The principles you learn in this chapter can be applied to just about any of them. And you can even look up online photographs of these systems. They can give you an idea of what you'll be working with as a security professional. And if you recall, as we learned in Chapter 9, a Cisco router is an enabled system that uses this Cisco Inter-Network Operating System, or iOS, to function. And that's really going to focus then the conversation. Now, some basic components of the Cisco routers to be aware of. Like I said, it may go by different names, but the same functions are largely applicable with other routers. There's RAM, or random access memory. This holds the router's running configurations, the routing tables, and buffers. And any changes you make to router's configuration aren't permanent unless you save the configuration. Then there's non-volatile RAM, or NVRAM, and this component holds the router's configuration file, but the information isn't lost if the router this time is turned off. There's also flash memory, which holds the iOS that the router is using, right? And it's rewritable, so you can upgrade the iOS, an important feature. A couple others include ROM, right? Read-only memory. And this is used to boot the router if the flash memory, for example, were to get corrupted. And then there are interfaces as some of the router components. An interface is the hardware connectivity point and the components you're most concerned with, right, as a security professional. An Ethernet port, for example, is an interface that connects the LAN to the LAN, and it can be configured to restrict traffic from a specific IP address or a subnet or even another network. So to see what information is stored in this memory, the Cisco administrator uses various commands, which we're going to talk about. And some of those access capabilities include user mode or privilege mode, right? So there are two access modes available in Cisco routers, the user mode and privilege mode. And the user mode has basic troubleshooting tests, and it lists information that you will need as a professional. Now, in privileged mode, an administrator can perform full router configuration tasks, and that largely is the distinction from user mode, which is basic troubleshooting, to privilege mode, which is full router configuration. Now, continue with the Cisco router configuration. The router name is followed by a symbol, and it indicates what user mode you're in. And the book shows you some examples of that. So a router name, so it's the symbol is the greater than sign, right? And so you will have your name within that. So the router name is followed by the hashtag sign, such as router hashtag, and indicates that you're in the privileged mode, right? Which is called the enable mode, right? So when you first log on to a Cisco router, you're in the user mode by default. And after you're in the privileged mode, then you can enter another command as you desire, right? So we want to talk in terms of global configuration mode. And in this mode in particular, you can configure the router settings, such as changing the router's display banner when a user connects to the router, say via Telnet. And the interface configuration mode. In this mode, you're configuring the interface on the router, such as a serial or fast internet port. Now, this table 13.1 you can find in the book itself. It describes some common commands for viewing a Cisco router components, right? And so the most critical configuration that security professionals perform is on the router's interface, right? Packets can be filtered and evaluated on a router's interfaces before passing to the next router or to the internal network even, right? So to control the flow of traffic through a router, access lists are used, right? And we'll talk more about access lists shortly. Okay. So there are several types of access control lists. This section focuses on IP access lists. IP access lists are lists of IP addresses and subnets with them, or the networks that are allowed or denied access. So there are two different IP access lists. One is the standard IP access list, and the other is the extended IP access list. Now, Cisco refers to IP access lists as, quote, access control lists, unquote, but refers to this specific file containing the list as an access list. So just know that sometimes Cisco goes back and forth. IP access list is referenced as an access control list, right? Or an access list. Now, the Cisco administrator who wants to restrict all traffic from, in this picture, from network 3, right, from entering network 1, they can create a standard IP access list that looks for the following access lists. And then, first of all, it can deny. So it can deny 173.110.0.0 with the particular subnet that I've highlighted in red. And then, of course, the last rule would be access list permit any, right? So it's going to deny this one group, but permit any otherwise. And so we can restrict IP traffic from entering or leaving a router's interface based on that source IP address, right? Which is what I'm trying to get at here by this example from the book. And then there are extended IP access lists. So if you want to restrict a user from sending a packet to a specific IP address, you can't use a standard IP access list. So you use extended IP access lists. And these can restrict IP traffic entering or leaving a router's interface based on the following criteria listed on the slide: the source IP address, destination IP address, protocol type, and application port number. So basically, it gives you a deeper dive. So you have these two levels of access lists in Cisco. One is quick, just based on largely IP address. The other gives a deeper dive, including the IP, but also the protocol type and the application port number, right? A deeper dive. So that's where I'm going to stop. We'll come back after the break. Thanks.